Let's look at another example of resistor color code calculation, this time with a 5-band resistor, meaning you have 1, 2, 3, 4, 5 colors. You will have 4 colors close together on one side of the resistor and a single color further away from them by itself on the other side of the resistor. That single color on the other side represents the tolerance. The color to its left will represent the multiplier, and then the other colors to their left will represent the digits. So here you will need the color code table to see the numbers that you'll need to work with. The first color is brown. What number is associated with brown? It is 1. So we have 1 for brown. Then the next color is yellow. What number is associated to yellow? It's 4. So we have 4 from the yellow there. Next color is purple. Which number is associated with purple? It's 7. So this is 7. Now what I want you to do is pause the video and finish off this question for me, and then let's see what you get. Remember, the 4th color is orange and the 5th color by itself is green, and you have the table here. Okay, so have you finished? What did you get for the range of resistances? Because it's really a range of resistances. Now, orange is the next color, the second to last color, meaning that it is the multiplier. Let's look for orange, and we see 3. Because you can see that for orange, the number associated with orange is always 3. So the multiplier is 10 to the power of 3. So for orange, you will have times 10 to the power of 3. Then the last color is green. So that will be the multiplier. I mean the tolerance. So your plus and minus. And remember the word tolerance, it means what you're going to tolerate. How much are you going to tolerate in terms of deviation from the average resistance? Alright? So you give a tolerance of plus or minus. Well, this is green, so let's find out. Green plus or minus 0.5%. So plus or minus 0.5%. All right. Now let's do our calculation. This is 147 multiplied by 10 to the 3 plus or minus 0.5%. So we have 147 times, what is 10 to the power of 3? It's 1000 plus or minus 0.5%. So we have 147,000. But we have a number of zeros to deal with. So we shorten it. What is 147,000? It is 147 kilo. So it's 147 kilo ohm plus or minus 0.5%. Now, the average resistance is expected to be close to 147 kilo ohms. But there's a tolerance. It may be 0.5% higher or 0.5% lower. Let's look at the highest expected resistance. It will be 147 plus or minus 0.5% of 147. And remember, we're dealing with kilo ohms. This is not 147 ohms, it's 147 kilo ohms. So here, 147 plus or minus 0.5% of 147. Let's just use our calculator here to get that value. So 0.5 divided by 100 is equal to, alright, multiplied by 147 equal 0.735 kilo ohms. 0.735. And the lowest resistance will be, for the highest, my mistake, it's just plus, not plus or minus. For the highest, it is 147. It's 147 minus 0.735. Now, we have the highest and the lowest. Now, what is the highest expected resistance of this resistor? Is going to be 147 plus, alright, and then we also have 147 minus. So we're going between 146.265 and 147.735. So it's 146.265 and 147.735. Alright, just to check back, did my memory serve me right? Did I remember accurately those figures? Let us see, 146.265 and 147.735. Nice. So these are in kilo ohms. So the average resistance is 147 kilo ohms, but it can be as low as 146.265 kilo ohms or as high as 147.735 kilo ohms. Now, it is more expensive to build a resistor where you have plus or minus 0.5 tolerance than a resistor with plus or minus 10% tolerance, alright? Because you have to make the chemicals, the mix of chemicals, more accurate. You have to spend more time and resources to make such a narrow band of tolerance than a higher tolerance, allowing it to be this high, to be so much higher or so much lower. Alright, but our answer here is 147 kilo ohm plus or minus 0.5%. See you in the next video.